So we've moved on to part B of our relative velocities problem, and part B says, what is the velocity of the bear relative to you? And that is important because the bear relative to you is a velocity we have not considered yet. The two other velocities that we were given were the velocity of you relative to the marksman and the velocity of the bear relative to the marksman. So this new velocity that we're being asked for is not relative to the marksman at all. It is the bear relative to you. So now we just have to figure this value out, and we are going to do this by an equation called vector addition. And vector addition looks something like if you have the vector of an A relative to an object C, this can be equal to the velocity of an A relative to a B plus the velocity of a B relative to a C. And all we really have to do is match up the variables or the subscripts that we have to fit this model here. So we can see that the letter C shows up in the denominator twice in two of these subscripts, and we have that our marksman, the relative to the marksman part, shows up in the denominator twice as well. So basically, we can reform this equation to start to fit our model. So we don't know which marksman won, either relative or us relative to the marksman or the bear relative to the marksman. We don't know which one goes here yet, but we can still start this equation. And the only other vector that can go here is the bear relative to you, because it does not have the C or the marksman in the denominator. And this will be plus the other vector, which one fits, relative to the marksman. So now we just have to look back at this example equation, and we can see that with these two vectors added to each other, the B shows up here on bottom of one and on the top of the other, and in a way it's sort of like the B gets canceled out, but either way, right here we have Y substituted in place for this B, so the vector that must go here must be Y, so that it's sort of like canceling out the U part of the equation, and we end up with the bear relative to the marksman. But we're still solving for this one vector here, the velocity of the bear relative to you. And that won't be a problem at all because this is really just an addition problem. So we just plug in our known values. We know the velocity of the bear relative to the marksman, and we know the velocity of you relative to the marksman. And so we just have to plug these in, and we can say that the velocity of the bear relative to the marksman is 6.93 in the x direction and 4 in the y direction, meters per second, which will equal the velocity of the bear relative to you plus, and then our other vector, 4.39 in the x direction and 4.09 in the y direction, meters per second. And it's just as simple as subtracting this vector here, the x and y, on both sides. So it's really as simple as that, and we just have to calculate that out so that each x component gets subtracted from the other. So it would be 6.93 minus 4.39 and 4 minus 4.09. And we get that in the x direction, the bear is moving 2.54 meters per second, and in the y direction, he's moving negative 0.09 meters per second. So what we've ended up with is a positive x value for our velocity, for the velocity of the bear relative to you, and a negative y value for the velocity of the bear relative to you. So it's like the bear is gaining on you in the x direction, but is not as fast as you in the y direction, or he's losing you. And so this is the vector form of the velocity of the bear relative to you. And just remember that if we ever wanted the magnitudinal value of this velocity, instead of the vector value, the magnitude of any vector is equal to the square root of its x component squared plus its y component squared. And then if you have a z component here, it would be under this as well, but we just have x and y. And we're not going to calculate this out because it turns out that since 0.09 is so small, squaring it and then adding it onto the squared x value barely changes the actual value. So with that, we have finished the problem.